Material testing. There are various different kinds of tests that can be conducted on engineering materials. You have destructive tests and non-destructive tests. This video will cover some of the common destructive tests. So you have tensile tests. This determines the tensile strength and behaviour of a material when under a tensile load. So it is done by putting a specimen in between two hydraulically activated jaws. It stretches the specimen until failure point, and this is used to create a stress-strain diagram, and it determines the characteristics of the material. Fatigue tests. So this determines the strength and behaviour when an object is undergoing cyclical loading. So that's simulating a load on an object over an extended period of time. For example, if you have a car brake pad, that's going to be subjected to lots of instances of compressive force over a long period of time. But obviously you don't have years of use to test this object on, so the fatigue test simulates that constant exposure to force to simulate what a couple years of use would entail. Failure analysis. So this is a visual test where an elastomer is bent or stretched until failure. You can do this type of test with other materials too, but it's most common with elastomers. And what you're looking for is at the point of failure, you're looking at what has happened. So if it's in elastomer, where is the tear? Where is the tear propagating to? So if you have a material that looks like this and there's a tear like that, and you see the tear propagating that way towards the point, then you know that there's probably a weakness along that line there, and that indicates features and flaws in the material. Static immersion test. So this is testing how a material reacts when it's submerged in water. So you submerge it in water for 16 to 18 hours, and you test the effects such as, is it starting to decay? Does it expand substantially? Is it weakened afterwards? And things like that. Moisture susceptibility tests. So these examine the effects of different liquids on surfaces such as asphalt. So this may determine if you have an oil spill on a road, is the road going to become unusable or start to decay? If there's some sort of acid, let's say you've got a pool truck that has some chlorine on it, if the chlorine spills onto the asphalt, is the road going to be destroyed? That's what those tests entail. Boiling test. So this is testing a material's melting point and how it will decay if it's overheated. So this could also be used on something like an asphalt road surface. You want to check in Australia, the sun can get pretty hot. If it's a really hot day, is the asphalt going to melt if it's exposed to direct sunlight? You want to test that to make sure that the mixture you're making is going to be able to withstand the environment it's subject to. So for geotextiles, these are materials that are designed to protect, insulate, filter, and block like weeds and stuff growing out of civil structures. They're made up of different fabrics, and they'll be explored in the later section. But you can test these using a swell test. You can test this with all fabrics essentially. So it's the susceptibility to swelling. So if you submerge an object in water, you want to test specifically how much it grows and expands. And this will determine the tolerances you need to include in your building and make sure that things aren't going to be too tight together or crack because something swells too much when it gets wet. Puncture testing. So this is the resistance to punctures of a fabric. So it simulates if you have a geotextile and something sharp on it, like a sharp rock or a bird claw, that specific force acting at a point, you want to test how much force it can withstand at a point without ripping or tearing or being penetrated. Friction testing. So this determines the coefficient of friction between two objects, and it can help you understand what's going on between the two objects. So is there too much friction? Is it going to create too much heat? Is there enough friction that you don't actually need a super strong adhesive between the two materials? Such as if it's bricks, can you use a weaker type of mortar since they're not going to be at risk of sliding apart anyways? And you can use a tensometer to calculate this. So you're basically just pulling along one side of the object and seeing what force is needed to get that object on the point of moving. And then you can use that to determine your coefficient of friction using the equation the force of friction is equal to the coefficient of friction times the normal force. So mortar compressive strength test. So this is the resistance of mortar to compressive forces. So you're basically just taking a sample of mortar and putting it in between two hydraulic presses, and in civil structures such as buildings or something like that where mortar is used to hold together bricks, it's crucial to make sure you're not overloading the mortar and it's not going to fail and crack and lead to the building failing. Mineralogical examinations. So this is mostly used for rock samples. So it's to determine the mineral content within the rocks. So it can be used to detect harmful substances within the material, such as asbestos, and it can also determine what the strength will be like within the material. So such as in granite, which is used in many building applications, you want to make sure that it has sufficient quartz, so that it has sufficient strength, and you want as minimal impurities as you can, so that it doesn't have big failure points, so it's not going to crack. So you basically just chop it open, look at it in a microscope. So for wood, you can do something called the wood density test, and this is testing how much mass is in a unit of space in the wood. So you subject the wood until it's at 15% moisture content, then you take a sample, measure on a scale, and calculate the density. The higher the density, the higher the strength the piece of wood will be, but it will become more brittle. The lower the density, the lower the strength will be, but it'll be less brittle and more ductile. So this is helpful when you're considering applications such as roof trusses within houses. It can determine the strength that you're going to get when it's at 15% moisture content. So that covers material testing. You don't need to know specifically all of these, but they're helpful to understand the basics behind how you can take into account different features of materials through subjecting them to different tests, so you can choose the most appropriate ones for the application you're using in civil structures.